Welcome everybody again for our second session today. The first keynote, which will be given by Alex Gantman, who is the Vice President of Engineering at Qualcomm Technologies and has been responsible for the security of Qualcomm products for quite some time. Alex is also one of the main hosts of the Qualcomm Mobile Security Summit, which has, as many of you will probably know, always addressed a very similar community to the Android Security Symposium. And if I'm informed correctly, the next edition of this Qualcomm Security Summit will be held in 2021. And we'll, of course, as organizers, will do our best not to have it collide as it so nearly did sometime in the past. With that, we're very much looking forward to your talk. Alex, over to you and to San Diego.
Thank you, Renee, for the introduction. Thanks for hosting me. When Renee invited me to speak, I asked him, okay, so what do you want me to talk about? He told me, like, anything you want to. So you kind of have to be careful what you wish for. So I reflected on, what can I talk about? And I wanted to talk about how I've seen kind of how my thinking about the evolution of security in the products that we make has evolved or has progressed, how I see that security evolving, and kind of what I see we can do to improve and accelerate that process. Let me see. Okay, quick intro, on top of what Renee already said. Like Renee said, my name is Alex. I work at Qualcomm. I've been at Qualcomm essentially, forever, since the end of last century. I joined as an intern. Here's before and after. I think Qualcomm has been pretty good to me. I think I've been, some use to Qualcomm as well. I've been working on security there basically since 2000. So I spent the last 20 years working on improving the security of mobile products. Used to be a real security engineer. These days, I mostly make slides badly. Few disclosures. It's still early here, so technically I haven't clocked in yet. So I'm here in my personal capacity, right? I'm going to be sharing some personal opinions. Please don't attribute them to Qualcomm. Please don't get me in trouble with my management. So I wanted to do something different today. I wanted to give an optimistic security talk because I'm that rarest of unicorns, an optimistic security engineer. This may come as somewhat of a surprise to those of you that know me, because I do try to maintain a fairly kind of solid facade of skepticism and devil's advocacy. But that's mostly just so that I can pass myself off as a real security engineer and fit in with my peers. In fact, I have the distinct honor of having been called the most depressing person he has ever met by Chris Evans. This was back when Chris led Google's Project Zero. And I think at some conference over drinks, I tried to explain how patching works in the mobile ecosystem to him. But nonetheless, I assure you, kind of deep at heart, I'm an optimist. And that optimism is not born of any sense of naivete, right? I've spent enough years in this industry to feel like I've really been, I've seen inside the total perspective vortex. I've seen the kind of the unimaginable infinite complexity of the mobile ecosystem and my own insignificance within it. A tiny marker, a microscopic dot on a microscopic dot that says you are here. But in spite of that, or as I'll talk more perhaps because of that, I have developed a rather kind of optimistic outlook. So I understand that kind of a cheery security engineer is a bit of an oxymoron and does not naturally engender trust and confidence. So I must first build up some credibility with this audience by basically, scaring you and telling you how everything is broken. So here we go. Okay, we're all doomed. Hold on, let me make this better. Okay, okay, there we go. Okay, so we're all doomed, and I have to admit, kind of, I was putting the slides together, this is not as shocking these days as it used to be, because, now, you open the news and you have this like infinite array of choices to be doomed by. But that aside, I'm talking about a very specific thing, particularly that we're doomed to never fully understand our own creations. And it's kind of, for engineers, it's hard to accept, right? Because as engineers, we have this God complex, right? Like, we're the creators. Like, I created this thing, and as the creator of this thing, I should be able to create it just to do exactly what I want and just what I want. Moreover, like, there's almost like a sense of entitlement that just because you create it, you have to really understand how it works. And it's not really kind of this sense of entitlement is not really supported by available evidence, right? This is kind of one cute counterexample. Like, any idiot can make one. Like, we made two, still have no idea how they work, right? Although, granted, this is a little bit out of realm of engineering. But the reason we will never fully understand our own creations is complexity, right? This is a somewhat random picture I got when I Googled for software complexity. This is a chart of relationships between classes in the Hibernate Java library, right? And you have to keep in mind that this in itself is, again, just a microscopic dot on a microscopic dot within some larger system, right? And kind of the details don't matter, right? I just wanted to illustrate, something that shows complexity. Perhaps a better choice would have been kind of like a modern system on a, the diagram of a modern system on a chip, but that would require me to talk to way too many lawyers. So I just Googled for something instead. So basically, and the complexity of the things that we're creating, the complexity of technological creations, is kind of rapidly approaching the complexity of living organisms. If you look at the kind of the number of transistors in modern systems, the number of bits of state in software, it is immense. And ironically, the very mechanism we use to cope with this complexity and to build even more complexity is the very thing that limits our understanding of what it is that we've built. And I'm talking about abstractions, right? Because abstractions provide a simplified model of the system, right? They provide a simplified model of the layer below to enable the builder, the designer, the engineer, kind of to free up their cognitive capacity to deal with more complexity at the layer above. And the keyword here is simplified, right? The kind of the paradox of the abstraction is that it can only be useful if it is wrong. Because if it doesn't simplify, if it doesn't hide some information, it doesn't provide its kind of core value. So I like to use this diagram to illustrate the point, right? We have a nice kind of simplified abstraction, straight lines, right angles on the left. We have reality, which is still a very simplified view, but bear with me, right? It's a bit more complex, right? You have the curved corners that are harder to model. And obviously, if you overlay the two, there's going to be some delta. And in our field, there's a very specific technical term for that difference between abstraction and reality, right? Like, we call it a vulnerability. And if you think about it, really most, if not all, types of vulnerabilities fit this metaphor pretty well, right? So, like, we miss buffer overflow vulnerabilities because the abstraction of a function call hides the kind of the detail of passing the return address through the stack. And we miss integer overflow vulnerabilities because the abstraction of arithmetic in C and its derivatives looks so much like the arithmetic we learned in primary school and hides the truncation and wraparound of the modular arithmetic underneath. And then we miss things like rowhammer because the abstraction of linear random access memory hides all the details of the physics of DRAM and how that works. In fact, this is also the reason why, in my view, so much of the security education is really about unlearning the lies taught in the core computer science curriculum. Right? So An abstraction, oh yeah, I should say, by the way, right, and if you zoom in, kind of this problem is fractal, right? Because again, the difference between abstraction and reality, reality is very messy, right? Like it doesn't have nice kind of straight lines. And again, the more you zoom in, the more kind of delta you see. So what happens is, right, like as a builder of a system, right, the designer thinks that they're working on kind of these solid layers, solid bricks with kind of no gaps between them that all fit in. And in reality, all of these vulnerabilities. And Sergey Brodus has this very eloquent saying: layers of abstraction become boundaries of competence. And that is, of course, what they're meant to be, right? Again, the abstraction is meant to hide the complexity of the layer beneath. But that means that kind of a person working at the top of this pyramid, right? Like, so a developer working on a cat filter for your, for some camera app, will never understand the full complexity, the full details of the entire system below, right? The language runtime garbage collection and the operating system permission model, and the CPU cache hierarchy, and the physics of DRAM and the chemistry of silicon dopants in the in the chip, right? It's not going to happen. Like, they will never understand the full thing. Like, and none of us will really fully understand how our computers work. But that's how modern technology kind of advances, right? Like, we keep adding layer upon layer onto this kind of tower, and really it's all kind of tightly packed layers. It's not just layers of abstraction, it's tightly packed layers of vulnerabilities. Okay. So hopefully that was sufficiently kind of demoralizing to convince you that I am indeed like a real security professional. And normally this is where a security talk would end, right? We're doomed. Thank you. Please don't forget to follow me on Twitter. Okay, I believe we have some time for Q&A. And that used to be me, right? Like, early on in my career, I actually got the nickname Dr. Evil. This was the early 2000s. Austin Powers movies were still popular. And I picked up a reputation for coming up with essentially these like movie plot business models, for $1 billion that attackers could build by exploiting different vulnerabilities. And keep in mind, this was before we could just say, hey, it's a bug, fix it, right? When we had to go through the whole dance of, well, but why would anybody ever do that? Luckily, we've sort of moved on from that largely. So anyway, like I said, so I got this nickname for all my dire predictions of how things will go wrong. And things were getting fixed, right? Like we had some success, but things were never fixed as quickly as you would hope. So I was perpetually worried about all of my dire predictions coming true. But years went by, and people went online and they banked and they shopped, and there was some crime, but there's always crime, and the overall crime rate went down. And like, cities did not burn down, or cities didn't burn, financial system did not collapse. Well, okay, like all of those things happened, but none of it happened because of a buffer overflow in a phone or anything like that, or in software at all. So after a while, I had to reconcile with the fact that the world kept on spinning. And that's what led me to kind of my current sunny outlook. That, a realization that despite all of this complexity, like even if we can't understand it, right? But despite all of that complexity, the products that we make, evolve a kind of resilience to the threats that they face in the world around them, almost like living organisms. So hopefully, some of you recognized the title of my talk, The Evolution of Secure Things, as a reference to Henry Petroski's book, The Evolution of Useful Things. And in this book, Petroski lays out the history of how kind of common household objects like the paperclip and the fork came to look the way they look. How did they get their current shapes? And essentially his central thesis is that form does not follow function, but form follows failure. And what he means by that is you don't get the shape of a paperclip, for example, by getting some smart person to sit down and think really hard about kind of, okay, what's the ideal kind of minimalist tool that, or mechanism that can hold a few loose leaves of paper together. Right. The way you get a paperclip is through, or anything else is through many generations of kind of iterative trial and error. Right. Somebody comes up with something and it works kind of okay, but then people observe the ways in which it is lacking and they try to improve on it. Like more precisely, kind of not every alteration is an improvement, right? Some alterations lead you kind of to an evolutionary dead end, but this, the process of trying and seeing what sticks and what makes things better is what eventually leads you to some ideal shape. Now, notably, he points out that this evolutionary process doesn't necessarily converge on one ideal form factor, right? On one ideal shape. The kind of most obvious example are eating utensils, right? This is, the problem of conveying food from, plate to mouth. This is all this time. This is something humans have been doing forever, and yet we see different cultures come up with vastly different tools for the problem, right? Again, most notably the fork and chopsticks. Right? So it's not like there's one ideal solution. You can have multiple solutions, and which one you end up with kind of depends on the evolutionary path you take. And when I read this book, I was struck by how much about Petrovsky's description about the evolution of everyday things resonated with me and kind of reminded me of how I view the evolution of security of things, right? Again, the similar thing is, how we keep trying things and we keep improving on the failures of the shortcomings of the past generation. And, I think some people view it as a failure of our profession that we don't get things right on the first try. But I'm not sure anything other than this kind of evolutionary approach is really reasonable to expect. And moreover, with most evolutionary processes, the outcomes are far better than they have any right to be. Right? And I think over time, commodity computers have become very resilient to the common threats around them. And look, they'll never be perfect, right? And there are always gaps, but they continue to evolve. I think understanding the evolutionary forces in play can help us speed up the process. And one of the most, I think, critical forces in play is consumer demand. So I believe that in consumer markets, in particular, security is, can be a differentiator. Security does become a differentiator, but it is the last differentiator, meaning that it really begins to impact purchasing decisions only after, the rate of introduction of new features slows down. So, when the product becomes commoditized, right? Like when all products more or less look the same, then people want reliability, security, and the broader reliability and safety. And we can look at a few historical examples, right? I think if you remember what it was like to buy a PC in the 90s, right? By the time you brought it home and finished setting it up, it was essentially an outdated pile of junk, right? Like you could go back to the store a few weeks later, buy something that was twice as fast for half the price. It's, every you would longingly look at every ad that came in about, what new computers are available and, keep dreaming about when you can upgrade. So in that climate, every time something went wrong, every time you had a crash, every time you had a virus infection, it was annoying, it was frustrating, and it was one more excuse to do what you really wanted, which is to get rid of this one and go buy a new one. Okay. Then at around 2000, the hardware is fast enough. We get out of order execution CPUs, we get hyper-threading, great things, never look back, right? The operating system is stable enough. Productivity software is great. Office has all the features you would ever want, plus the, paperclip thingy that pops up. And all of a sudden, you don't want a new one. You want this one to keep working, right? Like, yeah, you could go buy a new one, and the plastic is a bit nicer and the screen is a little bit crisper, but suddenly upgrading is a chore. You have to move all of your files and reinstall all your apps and reconfigure all the settings. And it's like, I just want this one to work, right? And so I think it's not a coincidence that Microsoft's big, trustworthy computing push, they're rolling out of their secure development lifecycle, came around that time, right? Bill Gates' trustworthy computing memo came out in early 2002. I think a similar thing can be observed in the automotive industry. And I know car comparisons are dicey, but kind of bear with me. And I apologize, a lot of my examples are going to be US centric, but I think they, hopefully they kind of carry over to other places as well. But at least in the US, right, kind of looking at the data, widespread availability of convenience features like FM radio and air conditioning and automatic transmission predate availability of safety features like seatbelts and airbags and anti-lock brakes. And again, as I said, like even the basics like seatbelts. And it's only kind of after cars become commoditized, right? So, what I remember about, for example, car commercials in the 90s and the early 2000s, they weren't advertising different features. They were all advertising crash safety ratings and warranty, periods, how long the warranty is, right? So by that time, all the focus has shifted to safety and reliability. That's at least until the more recent automotive renaissance based on computation and connectivity. And I think it wasn't all, Bucktrack and Ralph Nader either, right? Without dismissing or diminishing the role of activism, I think it's important for us to recognize the other forces in play and to understand why advocacy efforts succeeded at the point that they did. Right? Because it wasn't like Windows security was great throughout the 90s and nobody said anything, right? It wasn't like there wasn't, pressure on Microsoft to do something about it. And prior to Nader's book coming out, it wasn't like people weren't dying by tens of thousands every year in the US alone for decades leading up to that period. But something else happened in the market at that time to allow that transition. And I think we're seeing a similar thing with smartphones now, right? As we've made the transition from, so I would argue that today the smartphone is the most secure device, digital device that most people own, right? And it wasn't the case, 25, 20, 15, even 10 years ago, right? Probably, maybe even 5, I'm not sure about that. But once the rate of introduction, introduction of new features has flattened out, we saw this rather sharp transition of key market players to focus on security. And it's easy to forget how sudden that change was, and that it wasn't always like that. And it kind of makes sense when you think about it, both from the vendor and from the consumer point of view, right? So from the vendor point of view, security is not free, right? Security does cost money, and it costs time to market. So when you're in the mode where the rate of innovation is high and people want new features, and there's people are lining up around the block on product release day. A vendor that delays the release of their product to add more security in without kind of increasing the feature set, and that's almost a suicidal move, right? And at the same time, right, like looking at it from the customer perspective, we can see it as potentially a rational choice as well, though not necessarily kind of conscious and explicitly thought out. Because if you look at security as the ratio of benefit to risk, then during periods of rapid innovation, your best way to optimize that ratio may be to capitalize on the skyrocketing benefit, right? And it's only once that flattens out that your only way to improve that ratio begins to now kind of decrease the denominator and to draw down the risk. And look, this forum, I think, provides us with a perfect example, right? We're doing this on Zoom, right? Zoom is not exactly known for their security first posture. And yet the organizers, despite their considerable security expertise, decided that the features offered by the platform outweigh whatever security risks it brings. So clearly, from a business perspective, Zoom made the right call. Now having captured significant market share, they can afford to invest in security and make the program better, make the tool better. And of course, in essence, as consumers, we have endorsed that choice because that's the tool we chose to use. We didn't choose something that focused on security instead. And I think so cases like Zoom, right, bring up the question, okay, well, why can't vendors focus on security earlier on? Like, why don't we see more companies why do they leave it until the last minute? I think pictures like this help us to understand why, right? So this is, most of you are probably familiar with this picture. This is kind of the canonical illustration of survivorship bias. So during the Second World War, US military wanted to know where they should reinforce their planes, their bombers. And so they surveyed planes coming back from missions, and they mapped out all the areas that got hit by enemy gunfire, and they created this sort of heat map. And the initial proposal was, okay, well, clearly we have to reinforce the areas that are getting hit more. Until a statistician looked at it and pointed out that they're only looking at planes that survive the damage and return to base, right? The areas that are blank on this chart, it's not like enemy fire is miraculously missing those parts of the plane. The more likely explanation is that when that part of the plane gets hit, it is fatal, right? And planes that get hit in those places do not return to base. So rather than dealing with damage that's not fatal, that can be dealt with after the plane returns, they have to armor the places that are left blank here. So how does it relate to the topic that we're discussing? So I think similarly, I think there are lots of companies that focus on security early on. Unfortunately, the choices that we make as consumers, unfortunately, or maybe I shouldn't assign a value judgment to it, but the choices we make as consumers, these companies don't often survive long enough for us to know their names, right? Early on, focus tends to be on usability and features and things that consumers want and the benefit that they can get out of it. And only after that, companies begin to focus on security. Now, there's another reason why I think security takes this, go through this evolutionary process. And that's because the product itself evolves. You can't secure it until you know what it is. So like this is one of the early Qualcomm phones. I love this phone, by the way, probably still one of kind of my favorite phones of all time. But properly, kind of quote unquote, properly securing this phone in 1995 would have precluded pretty much every feature of a modern smartphone, right? Like, I mean, I can imagine a conversation. Right? Let me get this straight. You want to connect this thing to the internet, and you want to allow people to run third-party code on it. And I remember those concerns, right? I remember as phones began to add more and more features, camera and apps and so on. There were many kind of, especially within the security community, there was angst and concern that kind of this is greatly expanding the attack surface, which was correct, right? And people were saying, look, I just want a single purpose device. I want the phone to be a phone and nothing else. And while, again, as a security engineer, like those concerns were valid. Yes, the attack surface of a modern device is much greater than of a phone 20, 25 years ago. And yet, miraculously, I claim it is much harder to get remote code execution on a modern device than it is on the phone from 1995. So somehow this system of evolution works remarkably well. And I claim that actually the security of consumer devices has been a huge success. In fact, I'll go a giant leap further. I will claim that the software in consumer devices today is more resilient than anything the consumer market has ever seen. So think about some of the things you have in your house, right? Like an armchair, coffee maker, this is a bag, but say imagine glasses. I'm assuming everybody in this audience has glasses, eyeglasses. And these are all things designed for household use. They look nice, they provide excellent functionality, they're priced right for their target market, and so on. But they also all require careful handling, right? Like they're not designed to be abused in any way. I like to say there's nothing in my house that can survive a 3-year-old with scissors. Nothing. In fact, like the entire phrase, this is why we can't have nice things, is based on the premise that nice things require careful handling, and if we don't handle them really carefully, then they break. Now, there's another class of products that is meant to go into public spaces, like a park bench, train station vending machine, a shopping cart, right? These things are bulkier, they don't look as nice, they're not, the functionality they provide is very, very limited. They're a lot more expensive, but they can take, sun beating, right? They can take a scratch, maybe a baseball bat here or there. So the interesting thing is things like phones, like smartphones, are in both places at once, right? On the one hand, this is a consumer device. It has to feel nice and look nice and provide great functionality and be reasonably priced. On the other hand, the software it runs is connected to the internet, so it's essentially in the public space all of the time. And we now have this expectation that the software should be able to withstand not just kind of casual abuse from hyperactive kids and bored teenagers, but even targeted attacks from trained professionals. Now, pause for a minute to think about the significance of this change. This is a fundamentally different expectation than consumer goods, than we've ever had for consumer goods before. And really, I didn't think this was possible, right? Like, in fact, I looked at my notes. I have notes back from 2011 where I postulate that, consumer goods, including software, cannot be made vandal-proof because I just couldn't find a suitable preference. But, here we are. I mean, look at this chart from Zero View. And I know it's a marketing slide and we have to take it with a grain of salt, but anyway, what else in your house costs upwards of $2 million to break? Okay, and maybe remote attacks are not a fair comparison. Like, look even at basics like pin bypass and local privilege escalation. Like, who has a lock that costs $100,000 to pick? Who has a door that costs $200,000 to break down? Like, it doesn't happen. Right? So I think this is incredible, and I still find it hard to come to terms with this. Right? So I think whatever process is in play here is clearly producing very good results. And like, I'm not trying to say that, look, we just should sit back and enjoy the ride. I think we should look at what can we do to accelerate this process. And evolution works by iteratively trying new mutations and seeing what works and adopting that, right? So for it, you need two things, right? You need a useful utility function, some sort of a feedback metric. So whether it's survival in in biology or path coverage and fuzzing or whatever it is, right? But something to tell us that we're moving in the right direction. And and we want fast iteration. Now, I think in the context that we're describing, the speed of iteration is not an issue. I think we're iterating fast enough. I don't think we have a problem with, how often, how fast products come out, how fast we try new things. But I do think we have a problem with the utility function. I think, the feedback mechanism that the market provides kind of works, but it's really slow and imprecise, right? We never really know why a product fails, whether it's because of a lack of security or because of something else. So what we really want is some sort of rapid, accurate feedback to see if the change that we've introduced has made a thing more secure. And remarkably, kind of mind-bogglingly, we have no real way of assessing the security of the thing. And it's just mind-boggling that we've gotten this far in this field without being able to answer such a basic question. And in fact, so I'm going to do something now. I'm actually going to contradict something I said earlier, but it's a keynote. I believe I'm allowed to do that. So I'm going to claim that we actually have no idea if computers are more secure today than they were 20 years ago. So kind of follow me in this brief diversion. So let me ask this question about cars and car analogy again. Sorry. A car is safer to drive today than they were 40 years ago. How would we answer this question, right? Well, we can look at safety features, but safety features only tell us that somebody's trying. We don't necessarily know if they have an impact. We can look at safety tests. Again, safety tests, somewhat predictive. Like we think this helps, but we don't really know if that, if a car that does well in a safety test actually results in kind of a safer experience on the road. So ideally, what we have is actual data, like actual measurement of harm, right? So in the US, we have this data from the National Highway Traffic Safety Administration, NHTSA, right? And we can look at fatalities per year. And we can see that, yes, from the 1970s to today, the number of fatalities per year has decreased significantly. Now, there's a complication, of course, because the usage during that time has changed a lot as well, right? The number of people, the number of cars, the amount that people drive has increased drastically as well. So ideally, we normalize this kind of units of harm by units of benefit. So let's say we divide it by vehicle miles traveled, right? And when we look at those stats, we see that the change is even more drastic, right? There's almost a threefold decrease in the number of fatalities per mile traveled from the 1970s to today. So, so we can look at this data and say, okay, great, there's been progress. Now, we don't necessarily know specifically what led to that improvement, whether that was, speed limits or strong enforcement of traffic laws or seat belts or, global warming, whatever it was, right? But we can clearly see that there was improvement. So now we ask the same question about computers. Are computers more secure today than they were, let's say 25 years ago? So how would we answer that question? Like, what is the data that we would support our response? Like, what is our measure of harm? Like, we can't even agree on what units to use, right? Is it like ideally somewhere, right? Like we should be able to say, look, this hopefully 0 lives lost, but some measure of physical harm, some measure of financial harm, and then we want to again normalize it by measure of benefit. And I have no idea how we, like, what units we would use for benefit, right? Is it per number of transistors in the world, per number of bytes received or transmitted, whatever it is, right? And not having this, not being able to answer this question is really quite bad. In fact, like I think this is the biggest thing holding back our field. Now, personally, I try to ask myself questions like, okay, so if my budget was doubled tomorrow, like how would the users notice? Like what can the user points to say that, okay, their phone really got more secure? And I like to think that I'm in the business of harm reduction, right, or crime prevention. but I can't tell, to what extent I'm succeeding without data like this, right? And so, the automotive industry has NHTSA data on car fatalities that they can use to assess progress on car safety. And, the healthcare industry has CDC data on infections that they can assess improvements in disease prevention. And in the security industry, we have thought leaders, right? And for what we lack in evidence of what works, we more than make up for with like really strongly held fanatical beliefs about what should work. So I can try, we have a lot of, we have maturity models and best practices and guidelines, and, I can measure adherence to those. But if I do that, my job is not about harm reduction, my job is about compliance. I don't want to be in compliance, right? We can look at kind of decreasing negative press coverage based on CVEs or conference talks, but then my job is PR, and I don't want my job to be PR, right? Look, I know great people that work in PR. Some of my friends work in PR. That's just not my career choice. I want to be in the business of harm reduction, and for that, I need to be able to measure the actual outcome of my work. I know now that there are things like the cyber ITL, right, that look at, analyze the binary or analyze the product and look at which countermeasures are enabled, which unsafe functions are still in use and so on. But again, those things are like looking at safety features, right? It measures effort. How hard is a vendor trying to make their product secure? It doesn't necessarily tell you what the end outcome is. So in some sense, kind of going back to Zerodium's marketing slide, in some sense, this is the best feedback mechanism we have. And it's not a bad one, but it's not ideal, right? Like, and it's hard to tell how accurate it is. So kind of, I'm coming to the end here. I know we don't have a lot of time. So wrapping up, overall, kind of, when I look back at this slide, right, this is a very kind of happy, optimistic slide. Like, those are great numbers on the left-hand side to be looking at, right? And I hope, so looking at this, like, I hope that I've managed to deliver a somewhat optimistic talk, at least kind of by the security talk standards, and convince you that it's not all doom and gloom, and that consumer products are continuously evolving and becoming more secure, and that your smartphone is arguably the most secure device that you have. We can see the effect of this evolution, like even our threat models are evolving, right? To the point that, like, today, nation state attackers are explicitly part of the threat model. It wasn't like this. It wasn't always like this. It wasn't like this even 15, maybe even 10 years ago, right? Like, I remember starting out in this industry, and it was like an explicit position when you're performing a security analysis, when you're doing threat model. If government attackers are out of scope because there's not much you can do, and we've moved on since then. Now, I'm not saying we're successfully stopping every government attacker, but it's a realistic goal. It's a bar that we're actively trying to reach for, and that is a huge change for the better. So when I look at new kind of new fields like IoT, for example, I get a sense of deja vu, right? Because I see many of the same concerns coming up as what I was seeing during the early days of mobile. Many of the same concerns that I was raising during the early days of mobile. So, and knowing how that turned out gives me hope, right? So even as I share a lot of the concerns about the state of IoT security, I remain very optimistic about the fate, right? Look, that product category needs some time to mature and stabilize, to evolve, and then security of it will evolve too. Now, the reason I think you should kind of believe and embrace my optimistic outlook is my track record of being wrong. Okay, that sounded a bit better in my head the first time around. What I mean is, it's not just sort of some random thought I had. It is a conclusion based on a falsified hypothesis. In fact, many years worth of falsified hypotheses. Because I used to believe something different, and those different beliefs did not pan out, right? So I reconsidered them, and this is kind of this is my new outlook. So really, it's science, really. Okay, and I think that's actually it. So, those were the thoughts I wanted to share with you today. And I think we have some time for Q&A.
Thanks a lot, Alex. I was right in telling you that you could talk about anything you wanted. This was a great keynote. Thanks for being one of the remaining optimistic security experts here in the round, because we do need that at conferences. And I'm totally with you. Thanks for doing that, because I also strongly believe we are actually in a pretty good place at the moment. There are always things that we can improve, and I think we had some interesting talks these 2 days of where we can improve. But we are starting from a pretty high bar already. Also, thanks for the Douglas Adams reference. That's always a good one. Before going through my list of questions that I wrote down during your talk, we already have one in our virtual conference venue in the Mattermost chat from Daniel Thomas. Daniel, do you want to ask yourself, or shall I read it?
I can ask it.
Please go ahead.
So will IoT security only come when the number of providers has consolidated to a relatively small number, like with mobile devices, or say with big tech companies, you basically have to go with one of a small number, and therefore they have the reason to invest in security because things have settled down a bit? And if that is the case, is there any reason it wouldn't happen with IoT? I don't know, because of there being so many different application domains, or do you expect that everything will consolidate behind a small number and then we'll get security?
Sure. So that's an interesting question. Thanks. So I think the two, kind of the number of providers and the level of security, kind of thinking about it off the top of my head, I think there's probably some correlation there, but not necessarily causation, right? Like, I think the two may be driven by the same market forces, right? As early on in the field, there are lots of entrants, lots of people trying different things. As the field becomes mature, it kind of tends to consolidate to a few big players. And it so happens that kind of security evolves along, that same curve as well. And I think actually the kind of the slide I had in backup that I accidentally showed talks a little bit about that point. Maybe I'll go to it. Right? Let me just do that. Well, so speaking of IoT, right? Like, look, these two printers. A few weeks ago when I checked this, right? They think they offer pretty much the same set of features. They have the same price. How can you tell which one is more secure, or like is even secure, right? And maybe this is a counterexample to what I was saying before, that once a product category becomes commoditized, that's when it focuses on security, because these things are commoditized, right? Like, I think people go to the store and they just figure out, okay, like, I want a printer that costs like this much, or, whatever the cheapest, whatever is in store at Costco, and you just buy that printer. Right? There's not really a lot of, I think, feature differentiation for home printers these days. But then the question is, to what extent do consumers care, right? Like, how many of us have like our work, have a problem with the security of our printer, like can't get our work done because our printer, is being exploited, right? So, you could argue that, look, they reached the level of security that consumers are comfortable with, and if you made them 10 times more secure, like, nobody would notice, right? So yeah, so I don't know, this was kind of a long-winded answer. I'm not sure I answered the question directly, but I think we will see, I guess, that consolidation and improvement on security that are kind of, they'll go hand in hand, but it's not because one is related to the other. I think you can have many different vendors all improving security, but you do have to wait for the product category to mature. You have to figure out what customers are actually comfortable with, what benefit they're really looking to extract from a product, and what trade-offs they're willing to make in exchange for that, right? And you don't know that until you try, right? Like, look, I can look at Uber, right? Like something like Uber would have been insane to propose, like at any large corporation before Uber actually launched, right? Like, look, we're gonna, can you imagine that conversation with the legal team? Like, we're gonna let strangers like get into your car, and it doesn't happen, right? So you have to go kind of through this evolutionary process to see what sticks, what works, what consumers embrace, and then kind of work on securing that. Anyway,
coming back to your answer, at which point in your curve would you, in your time curve, would you put current mobile phones? Do you think we are already at the stage where the differentiating factor is becoming to be reliability? Or
yeah,
how far away from that are we?
No, I think for phones, my personal take is, look, and it's not a great thing kind of from a business perspective for the industry, but I think we've kind of turned that corner effectively, right? Like, all phones look like this, right? You don't really see lines forming around the block whenever the new, the latest phone comes out. People are not treating their, their 2-year contract as a prison sentence, counting down the days to when they can finally get a new phone. At least, like, look, for myself, right? It's like, it works well. I'm not necessarily looking forward to an upgrade. I know that, for me, really the last few generations of phones, like, the upgrade was driven by, battery life, the battery degrading and screens getting broken, right? It wasn't because the new phone offered the features that I wanted. It's because my old one stopped working. So in that sense, like, yes, reliability is already a thing. And yeah, like, at this point, I do view getting a new phone as a chore, right? Like, okay, now I have to migrate all of my stuff and reset it up. And again, not a great thing for somebody kind of whose salary depends on people buying new phones. But from a security engineering perspective, I do think we turned that corner, and that is why you see, like, I'm not naming names, but you see the big kind of players in the industry kind of made a rather sharp pivot towards kind of strong focus on security.
Coming quickly back to your example on printers, I fully agree that phones are becoming commodity devices these days, and there's a little difference in terms of features. But do you think that for phones, we already have like, as consumers, trying to put ourselves into consumers' shoes, do we already have the information? Do we have the transparency on how to decide between the security features, the security stance of multiple phones that you have in your short list of devices that you might go for? For printers, I agree. I wouldn't know where to look for if I wanted to know if it was safe to connect that printer directly to my whatever guest network or not. Do I know for phones if I'm not within this community here?
No, and I think that's the same answer, right? Like, unfortunately, no, right? And we don't have a good way. And like I said, I think part of it is because we don't really have this meaningful feedback function. We don't have reliable crime stats. What you really want to know is, okay, what is my likelihood of being exploited or losing money or whatever it is, right? If I buy this phone, right? I think we try to short circuit that and look at features, but I think it doesn't necessarily work, right? So, the worry is that like, it's possible to slap on a feature without actually making the device more secure, right? Like, look, I can, if I buy a cheap phone that's based on an SoC that's not from Qualcomm, let's say, right, and I slap a secure element to the side of it, it doesn't magically make it secure, right? It doesn't, like, address the hundreds of kind of LP and RCE bugs that are in there like that. So kind of adding a security feature by itself, right, just like adding a safety feature to a card, doesn't necessarily mean that you get the outcome that you want. We have to get to the point where we're actually able to measure outcomes and look back and say, okay, look, clearly, people that have bought this type of device ended up being safer than people that bought that type of device.
We do have another question in our Q&A session chat. You said, by Martin, by the way, you said we are past arguing if some bug is really going to be exploited or not. What do you think is the next argument that we should move past?
All right, so I guess I'm going to be, I'm going to keep beating that same drum. I think it's, I think we spend too much time arguing about whether something is a good idea, right? We're like whether a certain mitigation really works or not, whether, you know, kind of I'm thinking of, you know, hover flakes kind of mitigator and or kind of spenders kind of opinions on kind of what mitigations really work in Linux and so on. I think, I mean, they're interesting intellectual arguments, they're interesting academic arguments, but really we have to rely more on kind of on the evolutionary and the scientific process, right? You don't make progress just by kind of thinking really hard about what's a good idea and then stopping there, right? You have to then test it out and see if your hypothesis was correct, right? So again, we need this feedback mechanism that will allow us to try lots of different things and not get hung up about kind of philosophical or maybe arguments about whether a certain mitigation is good or bad. We should be able to look at the data and see whether that mitigation is working or not, right? Whether it's actually making users safer or not.
I have another one, which is very much connected to your take on reliability being one of the latest features that products aim for. Do you think that this curve will go down again? If I look at some product categories, again, let's not talk too much about smartphones because both of us would have to talk to some lawyers maybe. But if I think about whatever, washing machines, to take another example, it probably also works for cars. I feel that reliability is actually going down over the decades, that maybe it was an argument that your washing machine would run for 20 years. It no longer is one.
Yeah.
At the moment, we are back into the feature cycle. Hey, this washing machine speaks IPv6. Isn't that cool in itself? Wouldn't you want it because of that? So do you think that this is a curve that saturates at some point, or based on the product category and based on whatever the current market hype is, can it actually regress back down again? Is that something that you would expect also in the mobile and IoT space to happen, to have a little bit of back and forth?
Yeah, absolutely. I mean, I think reliability regresses. I'm not sure about security, but I mean, I don't necessarily see kind of in terms of that curve. I think it's just basically it's a second wave, so to speak, right? You know, using the terminology of today, you get a second wave, you get a third wave. In fact, I mean, we already saw something like this with phones, right? Like with battery life, right? Like, you know, the phone that I showed from 95, right? You know, back then, like we had a week of battery life, right? That was, you know, you want to be able to go for a week between charges, right? Like now we're lucky if we can last a day, right? And that's because obviously, you know, you have this kind of huge color display and a lot of other things, right? And a much more powerful processor. So you have certain kind of reliability things that are, they degrade because consumers embrace new functionality, new features. Yeah, so for washing machines, somebody really wants kind of is buying a new washing machine for kind of for Wi-Fi connectivity, and they're willing to kind of to trade longevity for it, then that's what happens. But again, right, you know, largely these are the choices we make as consumers, right? It's like in most cases, like you don't have to buy the Wi-Fi machine, right? Like we didn't have to use Zoom. We could have tried something more secure, but then it would probably, you know, I'd probably need more than 15 minutes for the AV check. I don't know.
Alex, I do fully share your concerns about the Zoom client. And as you so acutely mentioned at the start of your presentation, there are reasons why we chose it. Not only because our university actually has a campus license for that, which allows us to use all those features without paying from the conference budget, which we don't have. So yes, there are reasons. If we don't see any other questions right now, then I would like to close this excellent keynote session. Thank you again, Alex, for doing that. It was very much appreciated.